Today we are going to discuss about the rigidity modulus using this torsional pendulum method. To do this, the apparatus required are a cylindrical mass and a circular disc followed by two cylindrical masses of known weight, and this is a wire which is used for helping for the suspension. Apart from this, a screw cage is also required and a 1 meter scale. So these are the apparatus required. So with this apparatus, let me start doing the experiment. So as you have seen that in the first tabular column, we are going to determine the period of the oscillation of the disc at different stages. Now you might have seen that there are three rows are there. First row is mean for without masses, and the second is mean for masses at the closest distance, and third is the masses at the farthest distance. So what we are going to do is, so let me come back to the experiment. So without any cylindrical masses, now I am going to oscillate the cylindrical disc. You might have observed that there are two projections are there. One oscillation is nothing but the projection has to go to the original position in a clockwise, and it will come back to its original position. That is said to be one oscillation. In such a way, we are going to calculate for 10 oscillation and note down the time period. Sir, now I am going to give an oscillation. Let me count for 10. So I give a gentle rotation and leave it. So, and I am going to switch on the time period. So this is first oscillation, 1. This one is second oscillation, third, fourth, fifth, sixth, seventh, eighth, ninth, this is the final oscillation, that is 10. So total time taken here is 1 minute and 5 seconds. So instead you can straight away write it as 60 plus 5 is equal to 65. Where I have to write the reading here. It is 65 for the trial one. In the same way, I am going to do the repeat process. Before doing it, you have to reset the clock first. Then let me do the same procedure. I give a gentle rotation and leave the first oscillation to get down, and then I am going to switch on now. So this is oscillation 1, then 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we can see that it is exactly 60. Therefore, I write here as 60, and the mean of this is 62.5. This is for 10 oscillation, and therefore for one oscillation I have to divide this value by 10. that is 6.25. So this is the value of the period of oscillation without masses. Then let me place two symmetric masses which is very close to each other. Okay, then with the help of the scale, you have to measure the distance from the center to the center of any one of the symmetric masses. Here you can observe that the reading will be around 2.5 centimeters. So it will be around 2.5 centimeters. So I have noted down here as 2.5. Then let me repeat the reading once again by oscillating it in the same procedure. Let me reset this, and I'm giving a gentle rotation. Then I leave it. Let me leave for the first, and then we will start the oscillation. So we will try to avoid this kind of wobbling to get a perfect answer. So we will wait for 10. This is the second one. Third. Four. Five. 6. 7. 8. 9. 10. So totally it is 61. Therefore, with the masses at distance d1 for trial 1, I have written here as 61. So do the same procedure. Let me repeat once again. You start this, give a gentle rotation, leave it, let the first oscillation be continued, and we will start for it.